Welcome back to Code Snippets. Today we're talking about arrays. So what is an array? An array is just a list of values, or it's multiple variables stored together. For example, if you wanted to store a list of students in a class, instead of creating multiple strings, like if we said string student1 equals Michael, and then string student2 equals Jenny, and so on and so forth. Right, this would take forever and it would look very messy, and it would be hard to tell which student is which, who is student 1 and why are they student 1. So instead of doing all this, I'm going to comment these out. We can create an array of strings. So we say string, you list whatever data type it is, and then you put these square brackets, just like that. And so now this is our new data type, quote unquote. So then we need to give it a name, so I'm going to call it students, because it's a list of all these students. And then you can just put the semicolon like that. There's our declaration. And of course we still need to initialize that, and you can do that on the same line or a different line, doesn't matter. But we're going to say students equals, and then here we use our new keyword. So students equals new, and then you repeat the data type, and then we still need the brackets. And now here, inside the brackets, of course it's giving me an error, we need to put how many students we want to store. So if we want to store 10 students, we'd put a 10 in there, and now our error has gone away. So this is how you declare an array. Specifically, this would be a string array. And of course, if you wanted to put this on the same line, you would do so like this. Just like that. Same as all the other variables that we've created thus far. So, now that we have our string array, how do we actually store strings in it? Well, we sort of do it the same way that we did up here. So you'd have to go through and say students at 0 equals, and we'll say Michael again. Alright, so there's a bit to unpack here. Whenever we're talking about this array, we need to reference it by its name, the same way we reference all other variables. And in order to access the array, because when we just say the name of the array, we're talking about the whole thing. When we want to access a specific spot in the array, we use these square brackets, or bracket notation as I like to call it. So we say the brackets, that means we're going inside the array, and then we have the number 0 here. So the 0 is our index. Now, if I were to represent what an array is visually, this is how I would do it. So we have this sort of table here, and on the left side, I'm going to make that a little bit bigger. On the left side we have the indexes. I'm just going to put IDX. On the right side we have the values, or VAL. So when we're working with arrays, the index always starts at 0. So the very first index is 0, not 1. And that's just based on how Java does its calculations for memory locations and whatnot. All you have to remember is that you always start at 0. And then on the right side, this index corresponds to a value. So in this case, we said our array at index 0 is equal to Michael. I'm going to put Mike for short. Just like that. So you can almost think of, when we're dealing with indexes, you can think of that like a treasure map. So the treasure map itself is not valuable. It just points you to something that is valuable. In this case, 0 is not what we're looking for. 0 points us to what we are looking for, which is the name of one of our students, in this case Mike or Michael. So the indexes themselves are not variable. They just point to something that is, like a treasure map. And we also have the rest of our indexes, or indices. And if we go back here, we made it size 10. I'm actually going to change that. We'll make it size 6. So if we go back here, it's 0, 1, 2, 3, 4, 5. Now we don't go up to 6. This is where we stop. And that's again because we started at 0. That means there's 6 values here. So it goes up to 6, but it doesn't include 6. And that's because it starts at 0. If it started at 1, then you would go to 6, but it doesn't. And again, that's just based on how Java calculates memory. So I like to compare arrays to IKEA furniture, specifically like a dresser. When we go here, when we declare our array like this, we just say, hey, we're going to create a new string array, and it's called students. That's like saying, okay, I'm going to have a dresser, and it's going to go right here in my house, and you set aside some space for it. But the dresser doesn't exist yet. It's not in your house yet. You haven't built it. Nothing. You're just saying there's going to be a dresser here. Then when we initialize it, that's when we've actually built the dresser, and now it's in our house or wherever. So this dresser, we'll say it has 6 drawers, and that's what this number is doing here. So you've built the dresser, but there's nothing in it. So that's where you have to fill the dresser. So that's what's happening here. There's nothing in these 5 other slots, at least not yet. We still have to go through back here and say, like, students at 1 equals, well, back to Jenny, and then we could say students at 2 equals Richard. All right, and I can keep going all the way up through 5. Now, there's another way that we can fill an array that might be a little bit faster and definitely more dynamic. Because every time we run this, we're just going to have the same 3 students fill up the same first 3 spots. But what if we were able to ask the user to fill in 6 different students? Well, that's going back to the user input video I just did. Okay, if we're going to get user input, the first thing we need to make is a scanner. So scanner input equals new scanner system.in, just like that. And of course we need to import it. And then in order to actually get the input, first we need to ask a question. And to ask a question, we need to display the message, like enter 6 students. But of course we don't want to put the number 6 because that's hard coding, so I'm going to replace this with students.length. So here we're accessing the array that we just created when we say students, and then we're accessing the length property. So we're checking the array, we're going in, looking at it, and seeing, okay, how many indexes do you have? How many slots do you have for values that we can put in there? So in this case, we have 6 open spots, so we're going to have 6 as our length. So when this message gets printed, it's going to say enter 6 students, and if we run that, sure enough it does, enter 6 students. And if we change this to a 7, run it again, now it's 7, and we only have to change 1 value, we don't have to change 2 or more. Now, then we could say students at 0 equals, and we'll do input.next line, just like that. And of course we can copy and paste this over and over and over, but what's the point of that when we have a control structure that does such a thing for us? When you're doing something over and over and over, why not just use a loop? Now in this case, we're going to use a for loop, because a for loop has a specific end time. In this case, we only want to loop as many times as there are indexes in our array. And as you can see, one of the for loop functions built in automatically iterates over an array because they're so frequently used hand in hand. Now, a common misconception with arrays and for loops is when you want to fill an array, instead you would do students at 0 equals input.nextLine. That's the common misconception. However, if we run this, it's just going to fill the same exact spot 6 times. If we go back to here, when we say students at 0, let me write that out. That's always going to be accessing this first index, and therefore the first spot in the array. And then these will never get filled up. So we don't want to say students at 0. We also don't want to say students at 1 or anything like that, because it's just going to be filling the same exact spot 6 times. Instead, we want to say, okay, students at 0, but then go to 1, then go to 2, then go to 3, all the way down until we reach the end of our array. Now, how can we do that? Well, we need a variable that stores the numbers 0 through 6, but not including 6. Well, it just so happens we have a variable that does exactly that. And it's this I variable here, because I starts at 0, it's less than 6, and it goes up by 1 every single time the loop runs. So instead of saying students at 0, we can say students at I. And now, when we ask for user input, it'll fill index 0, then it'll fill index 1, then 2, then 3, so on and so forth. So let's run that, and actually at the end I'm going to print out the array. So when you print out an array, you can't just say sysout students, right? This will not work. I'm going to leave it in there and show you why it doesn't work. And then I'm going to print out the array the proper way. So we're going to say sysout students at I. So you need to loop through the array and print out every value individually, or else it won't work. So let's run this. So we need to enter 7 students. So Michael, Jenny, Richard, Stephen, Jessica, Molly, and Jake. Okay, so this line here, that's the product of saying system.out.println students. What's actually printed here is the memory location. So at 55F96302, that's a memory location on your computer. That's not helpful. That doesn't tell us anything about what's inside the array or what kind of array it is, other than this. We know it's a string array, but it's still not helpful. This, however, is a lot more helpful. This was the product of this. We printed out every student individually by using a for loop, and instead of just saying system.out.println students. Okay, so that was a string array, but what else can we do? Well, we can also make any other kind of data type into an array, no matter what data type it is. It doesn't have to be primitive, as I just showed. As I've mentioned before, string is technically not a primitive type, but it can be referenced as such, and we still made an array out of it. And we can also do so with an int. So we can say int, I'm going to call it nums, equals new int array, and we're going to make it size 10. And what's fun about having an int array instead of a string array is when we go through our for loop, we can actually just assign everything numerically instead of asking the user for input. So we can say like nums at I equals I plus 6, or something like that. Then we can print out whatever nums at I is. So whatever value it gave it, we're going to immediately print it out. And if we run that, we got 6 through 15, because we start at 0, 0 plus 6 is 6, all the way up to 9, because we don't go to 10. 9 plus 6 is 15. And you can even get a little more creative with it. We can say if I is equal to 0, then nums at I equals 10. Else nums at I equals nums at I minus 1 times 2 minus 13. Okay, now let's see what we get. So we assigned 10 to the first index because we checked if I is equal to 0, then we're just going to assign a value. Because if we say nums at index -1, you'll get an error. So I wanted to avoid that by only doing the I-1 when we knew there was a previous index. So we just assigned it a value, and we can throw that out here. We can say nums at 0 equals 10, and then we won't even need to start at 0. We can just completely skip that altogether. And this would accomplish the same task. So here's the output we have now. We run it, and well, we didn't print the first value. We can easily rectify that here. And now our output should look exactly the same as it did before. So this is kind of just illustrates there's more than one way to solve a problem if you're having one. Or just in general, if you have some sort of task you're trying to solve, there's not just a single right answer. It's just however you feel like you can solve the problem best. Whatever works for you. So we started at 10 as our first value. We said, okay, take 10, which was nums at 1 minus 1, that's 0. So 10 times 2 is 20, minus 13, that's 7. So that gets assigned to nums at 1. Then we printed it out. Then we go to the next value. 7 times 2 is 14, minus 13 is 1. 1 times 2 is 2, minus 13 is negative 11, all the way down to here. And now let's start with 20 instead. Let's see what happens there. Okay, now we got a bunch of positive numbers. So some cool stuff that you can mess around with and get some unique values and whatnot. But there's also another way that you can initialize an array that doesn't deal with for loops. Let's say we wanted to initialize an array of 5 values, all as the number 0. But I didn't want to use a for loop. Instead, we can just close the brackets like this, and then open curly brackets, and then just type in the values that you want to store. So if I want to store 5 zeros, I would just type out 5 zeros, like that, put a semicolon, and now I have an array of all zeros. Or I can make this one 20, and this one 13, and this one 26, and the rest 0, and I'll go ahead and print this out. Oops. My bad. So if you run it, those are the exact values that I just typed into the array. So if you notice, we don't specify a size here because it just takes the size of however many values you typed in. So I can keep adding to this, and the size would automatically adjust to however many values I put in. And one more thing about arrays that I can think of off the top of my head as far as basics are concerned. You also, just a very simple thing, if we want to declare an array, we don't have to say int brackets, and I'm just going to call it array, like that. Equals new array, I don't know, 10. It doesn't matter. This works fine. Oops, new int array. Or you can put the square brackets there instead. It's really up to you. I prefer putting the square brackets here because this represents our data type. So we have an array of ints that we call nums. But if it's easier for you to keep track of, well, I always need the square brackets after I write the name of the array, such as names or nums bracket I, then that's completely fine. It's really up to you. They both work exactly the same way. So whatever floats your boat. So that's the basics of arrays. In the next video, I'm going to talk about the for each loop, which I've mentioned a couple times.